Hi, I'm Yusuf Abdullahi. I work as a tutor at statisticassignmentexperts.com. I'm going to explain you solution of assignments. The assignment is based on um, a survey that was conducted to examine relationship between involvement in social activities and academic program. Results are presented in the table below. So assume that we wish to predict involvement in social activities using academic program as an independent variable. How much reduction in errors in the prediction of social activities? If instead we wish to predict academic program using involvement in social activities as an independent variable, how much reduction in error will occur? Be sure to state a verbal conclusion in each case. Finally, which is the better predictor? So this kind of question give us an insight. If we have two variables that we don't know which one cause the other, we can try and check uh, the reduction of error if we use one as the dependent variable and the other as the independent variable. Then we change it, use the other as the dependent, the first one as the independent, and see the change in the reduction in error. So the one with the highest reduction in error will be a better predictor. What I'm saying in essence is that, for example, if we are looking at a relationship between academic program and investment in social activities, are we can we say that involvement in social activities is predicting academic program, or academic program is um, is predicts involvement in social activities? So which of the two is a better predictor of the other? So that's what we want to look. So this is a cross tabulation. We see that involvement in social activities has three levels: high, moderate and low, and the academic program is art science and social science with the numbers here. So what are we going to do? So we need to find what is the reduction in error if we use academic program as the dependent variable and involvement in social activities as independent, and what is the reduction in error if we use involvement in social activities as the dependent and academic program as the independent. So we can we I will take you to how to solve this kind of question. So the reduction in error is given as E1 minus E2. E1 is the error of prediction made when the dependent variable is ignored. That is, if I make a prediction and I did not put the independent variable, E1 is the error of prediction, while E2 is the error made when the independent variable is included. So each E1 and E2 has a way to calculate. So E1 is n minus mode, capital N, where capital N is the total frequency, while the mode is the modal frequency of the dependent variable. So if we see from our results, we will see that the total frequency here is 165, and then the the mode, which is the modal frequency of the dependent variable. So we check the total here for the, don't forget we are using academic program as independent and so involvement in social activities as dependent. So we check the total for involvement in social activities. So we check which one is the mode. The mode is the highest value, which is 57. Then we have 165 minus 57, so which is 1/8. Our E1 is 1/8. Then E2, as we said, is the error of prediction when the independent variable is considered. Now if we put the independent variable in the mode in the model, so what is the error we are going to get? So our E2 is summation ni minus mode I. So ni is the total frequency for each category. That is, we have how many, we have three category of our dependent variable. So Ni is the total frequency 51, 41 and 73, while mode I is the mode of each category of the independent variable. That is, mode I is the mode here is 24, which is I. The mode here is 17 for moderate, and the mode here is 36 for low. Then we now go back, we see that our E2 will be total here 51 minus the mode here 24, as we can see, then plus the total here 41 minus the mode which is 17, and then the total here 73 minus the mode here 36. So we add everything, we add the difference. So adding this give us 88. Then the reduction in error, which is error made when dependent is not there, and error made when minus error made when dependent is there. Sorry, error made when independent variable is not there minus error made when dependent variable is not there. We see that the error is 108 minus 88, which is 20. Then we can now calculate the measure of association, how associated and how strong is the association if we take academic program as the dependent variable, and we take involvement in social activities as the independent variable, and this is given as E1 minus E2, that is this value all over E1, that's 20 over 108, we have 0.185. Then what if we reverse the case? Then we now use involvement in social activities as the independent variable, then academic performance as the dependent variable. So as we said earlier, E1 will be the total frequency 165, as we see here, minus the modal frequency for the independent variable. So we see for the dependent variable rather, so we see academic program is now the dependent variable. So we see that 73 is the modal frequency. So 165 minus 73 is 92. Then we find our E2, which is the error when the independent variable is in the model. So it will be this our independent variable. So it will be the total here minus the mode. The mode is 24. So we have 55 minus 24 plus the total here minus the mode. The mode is 22. So 57 minus 22 plus the total here is 53 minus the mode. The mode is 36. So we have 53 minus 36. As you can see here, we have 55 minus 24, 57 minus 22, and 53 minus 36, which is 83. So therefore the reduction in error is what? E1 minus E2, which is 92 minus 83. So we have 9. For the first one we have 20, this we have 9. Then the measure of association is E1 minus E2, which is what? 92 minus 83. Sorry, it should be 9. It should be 9. Then over E1, what is our E1 that we got 92. So we have 9 divided by 92. Let me check my calculator. So 9 divided by 92 is 0.098. So that's the measure of association. Then we can summarize our results. The dependent variable, the reduction in error is for academic program. When academic program is dependent variable, we should have independent variables here. So when academic program is the independent variable, so we see that reduction in error is 20 and lambda is 0.185, and when involvement when involvement in social activities is the independent variable, we have reduction in error of 9 and lambda of 0.00087. So this means that we have higher reduction in error when academic program um, is the independent variable, and then we have higher association, that is lambda value, that's the measure of association, then which means the association is stronger when academic program is independent variable. Then we conclude that academic program is what academic program is a better predictor, is a better predictor than involvement in social activities. So as we can see now, um, academic program is better to predict involvement in social activities than using involvement in social activities to predict academic program based on the results we have. So for any assistance with statistic assignment, uh, you can email to support@statisticassignmentexperts.com. Thank you.